me draw your attention to the front of the room here. We're going to start the proceedings now. As I think everyone here knows, this is the first Adolf Grünbaum Memorial Lecture, and I'm pleased to announce the circumstances that have made this lecture series possible. It's made possible through the generous support of the Barbara Grünbaum and Ron Gregory family and your donations. Adolf, our colleague and founder, died last year in November of 2018, and this is an event at which we come together to commemorate him and remember him. I can tell you a few things about him, but I can't tell you everything. So let me start out with the things that maybe matter to us the most here. In 1960, he came to the University of Pittsburgh as the first Andrew Mellon Professor of Philosophy, and he founded the modern tradition in philosophy of science that is now flourishing so well, as those of you in the room can attest. We are speaking as part of this event as part of the annual lecture series. Does anyone know a lecture series of this type that has been going for longer? Good. Then I can say without fear of contradiction that it is the longest lecture series of its type in the world. I'm pretty sure that that is the case. It's impossible here to review the importance that Adolf had to the University of Pittsburgh and to philosophy of science in general. He has a voluminous record of publication. He held many important positions across the field of philosophy of science, both within the university and outside of the university. I think it's fair to say that Adolf meant something a little bit different to everyone who knew him. There were, I think, many different Adolfs. So let me talk about a couple of things. Those of you who know him will know that he was a Ritchie boy. Now, what does that mean? He came to the US in 1938, coming from Cologne, Germany, fleeing the Nazis. And then by the end of World War II, a few years later, he was one of the interrogators sent by the US Army back to Germany to debrief and interview the captured Nazis. And that experience for him, he said, was formative. He interviewed quite a few of them. One of them was a mathematician, Ludwig Bieberbach, and he says, I looked this up in his autobiography, right? He said, I found it. Yeah, he said it was a formative experience because he saw so clearly in Bieberbach the betrayal of academic standards. Now, I remember Adolf describing the experience to me, and he said he was a real swine. I looked up in there and I could not find that particular remark. What can we say about Adolf academically? If you were on his side, he was your best friend and your fiercest ally. If you were on the other side, he was your worst nightmare. So we all have Adolf stories. And the reason I've put these photographs up here is I want to try and remember Adolf the person. When I look at these photos, I remember Adolf. This is a very young Adolf in his room up on the 25th floor of the Cathedral of Learning, holding court. And then you see in other photos of Adolf in our Center for Philosophy of Science giving talks. If one of them will come up when he's gesticulating wildly, I can tell you he is denouncing Freud at that moment. So we all have Adolf stories, and I thought the best thing I can do is tell you an Adolf story, one that I have, that maybe will bring him a little bit to life. So the story happened sometime in the 1990s. Adolf has been working on his trenchant expose of the folly of Freudian psychiatry, and he's decided to move on to his first love, which is a trenchant expose of the folly of theism. So he'd already written a paper in which he denounced the idea that, oh, there he is, that's wonderful. He's just delivering it perfectly there. He's just denounced the idea that you can find the act of God's creation in the Big Bang. And then he decided that it was time to revive his knowledge of cosmology. As things would have it, I happened to be teaching a graduate seminar in cosmology around that time, and so Adolf came to me and said, could he sit in? This seemed to me like, I don't know what philosophies call a category mistake or something. You want to come and sit in on. I tried to reassure him he would learn nothing at all. He said he was interested in the pedagogy. I don't really understand it. Anyway, you don't say no. This is Adolf. So he came and he attended regularly, and on the days that he could not attend, he would send an assistant to tape record everything that was happening, and then he'd listen to the recordings. Those of you who know Gualtiero Piccinini, that he was the assistant at that time. Anyway, one day Adolf doesn't show up, and he doesn't show up, and there's no Gualtiero to tape record, and then nothing happens. So, well, you do what you do. You just kept going, and then about 20 minutes into the seminar, the door opens, and there's Adolf. Now, of course, when Adolf appears, he makes an entrance. I mean, this is Adolf. Everyone's going to look and take notice of what's happening. And so Adolf, of course, says, no, please, no. Of course, that just makes the whole thing completely worse. And then he explains what happened. He says, with apologies, he'd thrown his back out, and he was in considerable back pain. He was wheeling his books in his bag on a little wheelie device, and he said, the only way that he could get from the car park into the seminar was to walk 20 yards and then lie down, and then repeat the cycle. Now, if anyone else had entered and told that story, it would have been, oh yeah, but no, we believed, because if there's one word that I think describes Adolf, he was absolutely tenacious, and he was going to come to this seminar, and so there he was. Okay. So now we have an interesting question. Who's going to be the lecturer who can inaugurate the Adolf Grünbaum Memorial Lecture Series? Right? We needed to find someone with great heft. Right? We need to find someone of academic gravitas. I don't mean to put any pressure on you, but you're it. And so I think, let's see. we think you're up to the job. Do you remember that?
I do. Yeah, I do. Those were the days.
So let me say a little bit about you, if you'll allow me to. I'll try not to embarrass you too greatly. So Michael comes to us from New Zealand. At the University of Auckland, he took degrees in computer science, mathematics, and philosophy, and then completed a PhD in philosophy at Rutgers, where he worked with, you told me, but who was it again?
Barry Lower.
Barry Lower, and also Stephen Stitch, right, as someone, and that's where he did the work that I like the best. This was the stuff on the interpretation of probability, which I recommend you to all of you. Since then, he moved through a number of positions, including positions at Stanford University, and then moved on to a small and struggling college in New York, New York University, and you arrived, and then it became the #1 university worldwide. So this is an achievement. I take it that I have the correct story. This is what happened.
It's indirect causation.
Indirect causation. You will know his works from reading many of his papers and hearing talks. He's, of course, I think best known for the Karyotic account of explanation. I think I see that pop up more often than other things in your work. He's written a number of different books, Bigger Than Chaos, which is on the probability stuff, Depth, an account of scientific explanation, Tichomancy, inferring probabilities from causal structure, and then a book that I know Edward loves very much, Thinking on Your Feet, How Empirical Psychology Vindicates Armchair Philosophy. It's your favorite?
It's a great book. Let's leave it at that.
And he will talk directly to us today on the topic of indirect causation.
Well, thanks very much, John. That was quite an introduction. I feel almost a little bit like a bit of an imposter coming here to give the Grünbaum Memorial Lecture, because in spite of having visited Pittsburgh quite a few times over the past years, as you have photographic evidence for up there, I never actually met Adolf himself. I mean, maybe I shouldn't even first name him, given that, Professor Grünbaum himself. But one of the pleasures of knowing in advance I was going to give this lecture and telling people is getting in response Adolf stories. And learning indirectly, unfortunately, just what a vital spirit he was, both philosophically and as a human being. Obviously quite something. So I'm very happy to be here, to be able to celebrate a little of that spirit. By talking about something which I guess is not one of his topics in particular, but I feel like if I torture it a little bit, I can make a connection. So of course he wrote about space-time, which is in some sense everywhere and nowhere. And indirect causation too is in some sense everywhere and nowhere, different sense. Everywhere across, I think, the sciences, and nowhere in the sense that well, first of all, it's not really causation. And second, in that it hasn't got anything like the attention that, given its starring role in scientific thought, it deserves. So let me tell you a little bit about it. Okay, now I'm going to do this tricky thing where I try to coordinate what's on my laptop screen with what's on this screen at the same time. So if you hear me talking about some topic that is in no way represented up there, just wave frantically and I'll see if I can resynchronize. There we go. Okay. I'll begin at the representation end of the story. So that is talking about the way that scientists talk about the world. Here's a headline this is the headline of a PR release, not a scientific paper, but it's advertising a scientific paper. Quite an influential one, proposing this hypothesis about the link between obesity and type 2 diabetes. The headline is about how obesity increases the risk for diabetes. The paper is about how there's something that increases both the risk of obesity and diabetes. As you can see from the short summary there. It's a high-fat diet, according to the hypothesis in this paper, and it doesn't really matter whether it's right or wrong, that is responsible for both and therefore responsible for the connection between them. So did the PR department screw up by using this causal talk up here, how obesity increases the risk for diabetes, when they should have said rather how something increases the risk for both and thereby causes a correlation between them? I mean, you can see why it doesn't entirely roll off the tongue. They might have thought they would get more attention with this phrasing. But I think more than that is going on. They're talking in an informal way in which it's okay to use a kind of causal vocabulary for something, obesity here, which is not a direct cause, but in a sense that I'm about to explain, an indirect cause. So I think what's happening here is it's not just that there's a correlation between these two things, that obesity in a certain sense, which I will explicate, is an indirect cause of diabetes. And this kind of talk is okay, maybe not in the abstract of a scientific paper, but in talk about a scientific paper to indicate that indirect causal role. So I call a statement like that an indirect causal generalization. An indirect causal generalization has this character. On the one hand, let's go that again. It's true because of a causal mechanism. But the antecedent property in the generalization, so that's obesity here, is not itself, as it were, does not itself play the starring role in the mechanism. It itself is not the cause that is setting this mechanism in motion or guiding it towards its target. we make a lot of these indirect causal generalizations, I think. And we need to, because causation, the actual structure of causal mechanisms is often not immediately evident from the world. That's why we need science, after all. Well, one of the reasons why we need science, to look into the world and figure out what's really causing what. So often we're in this situation where clearly something's going on. We suspect that there's a single causal mechanism at work, and we want to say something. We want to assert a certain causal pattern in the world. But if we were compelled when asserting causal patterns to actually name the cause, we would be stuck because we don't know the cause, as in the case of this connection, for example. So we need a way of talking about a causal connection without being able to name one end of that causal connection, the cause end. And I think that's what indirect causal generalizations are for. So here are some very simple examples, which I think are all indirect causal generalizations. They're all pointing to a mechanism, and yet the thing that occupies what we, in philosophy of science, have often taken to be the causal role is not really the cause, or perhaps I should say the property that occupies the causal role is not the property that's actually doing the causing. Example number one, these are the not so scientific examples. Bread nourishes, hemlock is poisonous, ravens are black. Here I nod to some fine philosophical traditions. In each of these cases, it's at least arguable that the property of being bread is not itself what's doing the nourishing. The property of being hemlock, which if the philosophers of biology are right, is about occupying some place in the great tree of life, is not what's doing the poisoning. And ravenhood, again, a taxonomical property, is not causing blackness. Instead, what we're doing here is we're using this property to identify a class of things in which a mechanism is at work that we're interested in this case, for practical reasons. Here are some somewhat less practical examples of the same thing. And I guess I'll read through them briefly without going into great detail. Shield volcanoes erupt effusively, that is, with a continuous flow of lava rather than big explosions throwing debris into the air. The obesity example, which I already talked about. Hunter-gatherers, so when they capture large animals, the successful hunters will bring them home and share them equally with everybody in the band. That's what this generalization is saying. And one more from the engineering world. Pre-77 Ford Pintos have a high chance, well, it's not that high, but high enough that you should definitely not consider driving one on the highway without modifying it, of exploding when hit from behind. Again, in each case, there is a property being used to pick out a class of things, whether it's a class of cars or people living in a certain economic situation, the volcanoes. And a mechanism is operational there. We want to know more about the mechanism, and we use this generalization to pick out a pattern. But there's more going on there, or I would be pretty much done already. And so really what this entire talk will be about is the more that's going on. These properties that are being used to pick out the mechanism here are not just any old properties. They enjoy a special kind of connection to the mechanism in question. And this is what qualifies those properties as indirectly causal. Okay. First of all, just to motivate this talk of indirectness, I should say something about what directness is. Directness, a direct causal generalization is one that simply names both the causally relevant property and its effect. So if I say F causes G in a direct tone of voice, I'm implicating the property F, Fness itself, in the causal mechanism. Now when I utter an indirect causal generalization, in spite of my opening example involving diabetes, I think we're much more likely to use this kind of generic talk than to use a causal term directly. So I say something like F star G. But of course, to understand this as a causal generalization is to give a particular spin to it, to understand it as not purely statistical, for example. But in the right context, we do this, and we understand what's being said to be this, which you will anticipate. This, and here I'm putting it very loosely, something about F's that causes genus. Okay. So that's the indirectness. Okay, here it is in pictures. We have some hidden cause that often we don't know the identity of, although sometimes we do. I'll hit that with the letter P down there, which is actually causing this property G. But our way into the relationship is through this other property F, which is not, or at least not necessarily, actually itself bringing about the presence of P. Okay? So it's this dashed line here that is introducing the indirectness into the proceedings. In the case of the blackness of ravens, for example, it looks something like this. The actual cause of blackness, as you can find out for yourself by consulting the raven coloration literature, is certain mechanisms in the raven physiology, which are not unique to ravens by any means, by which the pigmentation gets into the skin and the feathers and so on. The property of ravenhood, some taxonomic property that has to do with being, as I say, in the right place in the evolutionary tree, is not itself causing this, but it is connected in the right sort of way. Okay, so what does that all mean? Well, the aim of this paper, first I'll put it in terms that look towards the representational end of things. The aim of this paper is to say what must be true in order for an indirect causal generalization to be correct. So in other words, say what kind of fact that it is that you're announcing when you say ravens are black, or F's or G's in this causal tone of voice. And indeed, and understand these criteria as spelling out a certain, as I put it here, a canonical form for a certain kind of causal knowledge, but an indirect kind of causal knowledge, one that you can have without knowing the mechanism itself. And I'll be assuming here that there is, of course, a unified interpretation to have. And then I think of this as being at the same time as a story about how a particular verbal form is used in scientific communication, as also being a story about a relation out there, the one that's picked out by this verbal form, which I'll just call indirect causation. Indirect causation is often our first clue about direct causation. And in some sciences, it remains the main object of knowledge. So there are some sciences where ethnography is an example, where the remit of the scientists is not to discover the underlying mechanisms responsible for the generalizations they're recording. So an ethnographer is describing the culture of some society. Their job is not to do the cognitive psychology of the members of that culture. Rather, they stay at the indirect causal level, saying things like hunter-gatherers share large food items, or the results of their hunts equally. They live in this sort of way. Their political organization has this character, in this case, a rather democratic character. There's certain levels of violence prevalent in hunter-gatherer bands, if in fact there's any stability to that whatsoever, and so on, to make these generalizations about certain groups or kinds of things without ever going into the underlying mechanisms. So some sciences deal primarily with indirect causes, others like medical science are, although they often deal with indirect causes for want of anything better, are also very much interested in mechanisms. Okay, that's my aim. So it's all going to be about these criteria for making indirect causal generalizations, and therefore to put it in a more metaphysical way, the nature of indirect causation. Okay. So here's that picture again. These are the players in an indirect causal generalization: the underlying cause, the effect, and the thing F, which stands in the antecedent role, often thought of as the causal role in a causal generalization. And what I'll be focusing on, needless to say, is this part here, the dashed line. I'm not going to talk about the nature of direct causation at all. I'll just assume that we have some understanding, or will one day have some understanding, if our philosophers of causality ever get down to work and do their job, of what it is for one property to directly cause another. And simply talk about what connection has to hold between F and P for me to be able to say that F is a direct cause and not merely, say, correlated with G. Okay. Now the way I glossed that in my initial presentation is this. I said what we're doing is we're saying something about F's causes G. And I think that's a good place to start. Of course, it's rather vague or ambiguous. The question is, what do we really mean when we say something about F, something about hunter-gatherers, something about ravens? What is this connection between F and P? Okay. I have a name for it: entanglement. Somebody told me this has been used before for something. I figure there's no possibility of any confusion. And in fact, there's a certain resonance. You know, indirect causation, it's kind of causal and it's kind of not causal at the same time. So there is a certain conceptual quantumness to the whole deal. I'll press on with this terminology. So entanglement is a real connection, not necessarily a causal connection though, although causation may have something to do with it. That our indirect cause, F, and as I've set things out, bears to some underlying property, at least in the context of this talk, the real cause of the phenomenon we're interested in. Okay. What the criteria for a correct indirect causal generalization is going to look something like this then. It's okay, it's correct to say F's a G if, first of all, you have that mechanism there, and second, you have entanglement. So number one corresponds to the arrow running from the perhaps unknown cause P to the causal consequent G. Number two corresponds to that dashed arrow that represents the entanglement. Okay. Equally, you could take this in a more metaphysical spirit to be giving a story about what indirect causation is. But as you can see, it's the same story. It's indirect causation is a concatenation of two things. First, entanglement, and followed by causation itself. Okay. Needless to say, I guess I'm simply repeating myself here, I'm going to be concerned with the entanglement half of this story. All right. What is this thing we call entanglement? First, I'm just going to hit you with a list of criteria for entanglement, okay, without any apologies or explanation. And then I'll go back and talk about them a little bit. And then I will say some things about entanglement, which I hope will be, I was going to say controversial, which I hope will be interesting, revelatory even, because they will show you that indirect causal generalizations have certain properties and are able to function in certain ways in scientific thought and practice that qualify them as leading contenders to be the kind of generalization around which we build many of our sciences. Not the fundamental laws of physics, but maybe just about everything else. Here they are, the criteria. First of all, a robust connection between F and P. You were probably expecting something like that without the robust connection, of course, where it's hard to see how any of this would get off the ground. But there's more. P has to be an intrinsic property of the F's. Okay. And furthermore, Almost all the F's have to have P for the same reason. And finally, almost everything that has P for that reason is an F. So to put this in Raven terms, where F is ravenhood, P is the Raven coloration mechanism, whatever it is, and G is blackness. Okay, we need a robust connection between being a raven and possessing this coloration mechanism. The mechanism has to be intrinsic to the ravens. Okay, it's got to be inside them. It doesn't count if someone is going around spray painting ravens black. Almost all the ravens have to have the coloration mechanism for the same reason. Okay, in this case, it's going to be something to do with reproduction and development of the raven physiology. And almost everything that has P for that reason has got to be a raven. So whenever you have the raven physiology, whatever it is, passing on and creating a brand new coloration mechanism in a new organism, it's got to be that organism is a raven. Okay, I'm going to collapse 3 and 4 together, okay, because they really, one of them goes one way and one of them goes the other, and we can have them all in a single statement like this. There's a single shared reason for this connection between F and P, okay, and that unites all the instances of F and the possessors of P. So this is quite a close connection between these two properties now, the way I've set things up, much closer than just a robust connection. Okay, and it's going to be that additional closeness that qualifies F to do some things that perhaps you thought only causes could do. Well, just to give you a preview, to do one thing in particular that you thought only causes could do, which is to explain. Okay. All right. So let me now talk a little bit about these 3 items independently. The robust connection. Okay, this is probably I don't need to say too much to convince you, as I said, that something like this has got to be the case. The F's have to have at least a tendency to have the underlying property in question. And this has to be, when I say robust, I mean both actually and counterfactually. If you don't love counterfactuals, stick with robustness. But the idea is it can't just be an accident that the ravens have the mechanism they do. There has to be some solid connection, so that, one way to put, so I have put it counterfactually here. If we had, first of all, actual ravens, but just imagine them living in somewhat counterfactual circumstances, their lives go a little bit differently, they still would have had this coloration mechanism. It's pretty firmly implanted within them. And we can imagine ravens that might have existed, two ravens, soulmates separated by a continent. They never, maybe a fleeting glance, but they never consummate their love. But had they, the young ravens that would have been a product of that relationship too would have had the coloration mechanism. So that's all I mean by robustness. Okay, and like I said, it's really just an attempt here to unfold a little bit what I think people generally mean when they say there's a tendency here for the ravens to have the mechanism. Okay. Intrinsicness. Okay. I should maybe say straight away that it doesn't have to be the case that everything about the mechanism is inside the F. So in the case of the ravens, certain background conditions are necessary in order for the coloration mechanism to express itself. The raven has to receive appropriate supplies of various things like oxygen and food. These background conditions must be present. They need not be in there, but the kernel of the mechanism has to be in there. And I won't say anything more about what I mean by the kernel of the mechanism, although that's a good topic, but just to get on with things. But I think we have some sense, which I'm not elucidating here, of the mechanism versus the conditions, and what's being asked for here is the mechanism being inside. Now, why should intrinsicness be a part of what it is to be an indirect cause? I think one reason, and this requires you to think of these indirect causal generalizations as a kind of a canonical form for expressing, for communicating knowledge, causal knowledge, is simply this, that if we have the intrinsicness requirement, then whenever we utter an indirect causal generalization, we're telling people where to look for the cause. If I say, ravens are black, and I mean it as an indirect causal generalization, I'm not just saying something out there is causing ravens to be black, I'm saying something in there, in the ravens themselves, is causing them to be black. Likewise with, say, the Ford Pintos. Something about the actual insides of the cars that gives them this tendency to explode, and so on. So we're putting a slightly, in adopting this requirement, if you think of us as doing this voluntarily, in adopting this requirement, we're making it more difficult to assert a correct indirect causal generalization. An additional condition has to be satisfied. But at the same time, and it's just the other side of the coin, we're saying more when we do assert one. Okay, that's intrinsicness. Now that single reason thing. So one way of stating this is to say that entanglement is individuated explanatorily. That is, one explanation, one entanglement relation. There's this robust connection that has to be there. And what we're asking is that Fness, the property, gathers together under its umbrella the things and just the things in which that explanation applies when p-hood is around for that reason. And I think it's a question that also needs to be asked is why do we do things this way? I mean, for that matter, why do we even direct causal generalizations? Why do we, I think there's good reason to think when we utter direct causal generalizations, we also individuate them explanatorily, that is by causal mechanism. Okay, so when I say to you that in a more directly causal tone of voice that drinking coffee makes you wired, even that's probably indirect. It's very difficult to find the direct ones. What I'm doing is I'm suggesting that there's a single mechanism that's doing the work. And I think that the one way to understand the reason that we do things in this way is that these generalizations typically have exceptions. Okay, certain conditions have to obtain if they're going to go through, as it were, and sometimes those conditions don't obtain. And what those conditions are that are required to obtain depend on the kind of causal mechanism and more generally the kind of explanation. So by dividing generalizations up explanatorily, so there's just a single explanation for the entanglement and then a single mechanism that implements the causal connection as well. What we're doing is we're dividing them up according to what people sometimes call ceteris paribus conditions, the conditions that have to hold for as I say, for the generalizations to go through. So we're kind of, as it were, packaging our patterns, our regularities, and as best we can. Of course, we don't always get it right. So that we can come along and subsequent investigation will be able to associate each one with a different kind of story about how to, as it were, complete the generalization, stating all the conditions under which we can expect the generalization to go through, or equally all the conditions under which we can expect it to fail. That's my best guess as to what's going on here in this practice of uttering generalizations overall. Okay. Now I want to talk a bit about the reasons why things end up entangled. So to be entangled just is for F and P to be entangled just is for there to be a robust connection, for P to be an intrinsic property of the Fs, and for there to be this single reason, and just about gathered together under the umbrella of the robust connection. But why? Why would you get this satisfaction of these criteria? There are a number of different reasons why you might get it, and they are really quite different. So first of all, there are metaphysical reasons for entanglement. Okay, this is not going to be this isn't going to be the bad kind of metaphysics. This is just going to be the kind of metaphysics that everyone is down with. For example, I know. For example, well, I'll just give you two ways this can work. And one is simply identity. So identity is a metaphysical relation. It's one I think that we all recognize as being fairly unproblematic. Although you can still have an identity crisis. But it might turn out that the property you're naming as the indirect cause turns out itself to be the underlying direct cause. And I think there you have, in a very trivial way, you have identity. And if you actually go through, you can tick all the boxes for an entanglement. So it's one reason why you might. It's important simply because it allows indirect causal generalizations to turn out to be true in virtue of the antecedent property being itself the cause. But sometimes too, what will happen is that the underlying cause is constitutive in some ways of being an F, whatever an F is. So if, for example, you had a story about what ravenhood was, where being a raven is having a certain kind of physiological makeup, I think most philosophers of biology would reject that story because they would say a molecular duplicate of a raven is not a real raven because it doesn't have the correct phylogenetic relationships to the real ravens. But you might think that's wrong. That what it is to be a raven is to have that physiological makeup. Well then, in that case, having the coloration mechanism would be constitutive of ravenhood, and the entanglement would be there because of this constitutive connection. Okay, so that's metaphysical reasons. Then there are causal reasons. Suppose, in particular, so this is a kind of a common cause explanation, that the typical cause of F also typically causes P. So when you find F, it's usually because such and such a thing has been causing it, and that thing also causes P. So you'll have the right kind of connection there between F and P. So, for example, in the case of the shield volcanoes, what typically causes a shield volcano to form. So these are the very shallow, broad volcanoes. The typical explanation for a volcano having that geometry is that the lava that erupts is very liquid, and so it runs very swiftly down a slope and builds a gradual, wide mound. And that's also that same mechanism that creates the shield is also creates the effusive nature of the eruptions of shield volcanoes. So when you have the connection between being a shield volcano and effusive eruption, the right story to tell is this common cause story. But this isn't the most common, I think, reason for entanglement. Often we get entanglement. This is particularly true in the biological world because of what some people have called frozen accidents. I got this term from Ken Schaffner, actually, but I don't know where it ultimately comes from. So the idea is this, that you have your, at the beginning of Fness, so think of ravens or some biological group or could be some social group. P-hood was strongly represented. It may just be by coincidence. You know, the founder population of the ravens, when they first broke off from whatever group they broke off of, happened to be rather darkly colored. Okay. But then there's a mechanism that reliably transmits that character of the population to future populations, and maybe even mechanisms that reinforce it. So ravens have to recognize one another, and they maybe recognize one another by their darkness, and this actually encourages the development of ever deeper shades of black. Okay, we were having a discussion over lunch about whether this could really be true of the ravens, but I'm a philosopher, so it doesn't matter. Oh, no, wait, I'm a philosopher of science, so it does matter. Well, never mind. So in a case like this, it's not the case that, in fact, that Fness here even has to be caused. And you might think of ravenhood as, and other taxonomical properties, are not even the kinds of things that themselves can be causally brought about. It's rather just that F's started out having this property, and there are mechanisms that transmit that property reliably into the future. Another case of this, which is not biological, I think, is the connection between being this planet and having a plate tectonic structure in geology. So we can make lots of generalizations about the Earth in virtue of its plate tectonic geology. And people were making those generalizations before we understood plate tectonics. And they were attributing to the Earth certain properties. But the properties are there not because there was something that kind of, as it were, I mean, in this case, the antecedent property is really just the property of being a certain individual, namely our planet. It's not because that is caused by any particular cause, that property, I mean. Of course, the Earth has a causal history. It's rather simply that the Earth started out with the structure, and the structure is a very stable structure, and so it's continued to have that structure. So this is the case where we have the right to assert certain indirect causal generalizations, geological in this case, in virtue of an entanglement that is ultimately due to the fact that things started out a certain way. Maybe one day we'll understand a little bit more about which planets come to have a plate tectonic structure and which don't, but without knowing anything about that, we can know that it's okay to assert the generalizations because the criteria for entanglement is satisfied. All right. And I'd love to go on and on about how important indirect causal generalizations are in the sciences, how again and again, when you look at the sciences and you look at the kinds of generalizations that are being made and that are thought to summarize the causal knowledge of those sciences, look at particular models in those sciences and look at the generalizations that, as it were, constitute the causal knowledge that goes into the models. That information is packaged in this form as an indirect causal generalization. That is, as a generalization where the antecedent is reasonably thought to be entangled with an underlying cause that's responsible for the consequent. But I'm not going to survey all the sciences. I'm going to give you one example and then I'll ask you to extrapolate wildly. Okay? I'll use an example of a population ecology model, but I hope you see that really it could be just about any kind of model. So here's a model from a famous old population ecology paper that's about the pine forests of southwestern Ontario. Okay? And the authors of the paper built a model of the population of sawflies and how it changed in various respects, depending on the presence of the main predators of the sawflies, tiny mammals. Okay, and that model, the point of the paper was to at least part of the point of the paper was to at least say this model is a fairly good model of the change in the population. And part of that model is claims such as this, that in these ecosystems, the reproduction rate of sawflies is such and such, or maybe falls into a certain band, or has a certain functional form that depends on other high-level properties of the system, such as perhaps the presence of certain weather patterns and so on. But anyway, you get the idea. A generalizations like this are the engine room of any model like this. And what I want to do is encourage you to think of these claims as being indirect causal generalizations. Okay, they single out, they name a property, namely being a sawfly in a pine forest in southwestern Ontario. Okay. So in this case, it's more specific than being a member of a species because we want to bring in the whole ecosystem here. That's going to be important to the accuracy of the generalization. And then they say something about the things in question, that they have a certain reproduction rate. Okay. And we should be understanding what's being said as an indirect causal generalization. Okay, it's something that the being a sawfly in this ecosystem is a property, but it's not a property that itself is causing the reproduction rate to be like this. Rather, that's particular properties of the sawflies and their surroundings, but in particular of the sawflies, of course. And what's being asserted rather is just the right kind of connection between that property, the property that's being named, and the underlying causes. Okay, so the antecedent property is the indirect cause here. Okay, like I said, that's. I think you can extrapolate this to modeling practices across the sciences and see that indirect causal generalizations potentially have an important role to play. And you can ask yourself, is it really true that they're typically built around indirect causal generalizations and not direct causal generalizations, or maybe some much looser form of generalization? So I encourage you to ask that question. I will just assert that I think you'll find the indirect causal generalization is not, it's not illegal to use some other form of generalization, but it's the standard form in these cases. Okay, now I get to talk about some of the properties of entanglement, in virtue of which the generalizations that we find in science have some of the distinctive properties they do. Okay, and there's two in particular I want to talk about. One is exceptions. So there's been quite a bit of head scratching in the philosophical literature about how special science generalizations come to have exceptions. Now it could of course be that the world is just a kind of incontinent place, and what brings about an effect at one time might, even though circumstances are identical, fail to bring about that cause at another time. I think that view is made a lot of sense, for example, to the ancient philosophers. Aristotle thought there was a lot of, for the most part, going on. But it's more puzzling in some ways to a modern philosophical sensibility why our generalizations should have exceptions. If we think of a certain mechanism as being ultimately based in the processes of fundamental physics, then it seems like it should be possible to frame a generalization, a causal generalization that is exceptionless. I mean, it may be that it's rather a lot of effort, but it should be that our goal is to frame generalizations that are exceptionless. Yet that does not in fact seem to be the case. It seems like we're perfectly happy with a practice of asserting generalizations that come with exceptions. And I think one of the main reasons for this is that our generalizations are typically indirect, and that entanglement, as I put it here, in a way that causation often doesn't, tolerates exceptions. So the very nature of entanglement, as I've characterized it, has a bit of slop. It has a bit of, for the most part. Okay, it's okay if F is entangled with P for there to be some Fs that lack P. Okay? That is, some ravens that lack the raven coloration mechanism. Something goes wrong in the developmental process, and some particular raven doesn't have it. Okay, so in these cases, it's possible, even if you have a mechanism that, given the appropriate background conditions, invariably produces a certain consequence. So in the case of raven coloration, it may be that, of course, it's not the case that if you simply have the bare bones of the mechanism, it invariably brings about blackness. But when the necessary background conditions are satisfied, the raven is getting the appropriate nutrients, the appropriate oxygen, and has a certain amount of physiological integrity, the environment is the right temperature, and so on. Once you start adding a list of conditions like that are by no means inaccessible to us, it starts to become plausible that, that the coloration mechanism, when the background conditions are satisfied, almost always brings about blackness. But there are white ravens. And why is that? Well, the reason is that not that the coloration mechanism is fallible, but that some ravens simply do not possess the coloration mechanism. And entanglement allows precisely for this possibility. So entanglement allows us to have exceptions, and even in a world where causation typically is exceptionless. Therefore, there are leucistic ravens, which are ravens that are white for one reason or another. Okay, there's just some part of the mechanism for blackness is missing. There are some pyroclastic shield volcanoes, so that shield volcanoes that erupt explosively rather than effusively. And again, it's because the expected mechanism is not there, not because the mechanism is behaving badly, and so on. Okay. Coming up next. Yeah, that's all I'll say about exceptions. Now, that's a negative, although I think it makes sense of an enormous amount of non-strictness in the generalizations that lie behind our generalizing practices in the sciences. Now, here's something a bit more positive, which I already previewed. Entanglement, I think, is explanatory in a certain sense. I better get on with this and explain exactly what sense I have in mind here. I mean this. It's okay, I believe some eminent philosophers of science may have preceded me in making this claim. It's okay to give a kind of covering law explanation of this form. Hempel famously used the example, well, Hempel of course gave us the blackness of ravens, but when he was talking about explanation, for some reason he preferred to explain the color of robins' eggs, the blue color of robins' eggs, by citing the law that robins' eggs are blue. Okay? So in this case, what we're being told is I can explain the color of these eggs or the color of this bird simply by pointing out to you what kind of bird it is and citing the appropriate law. And there it seems what's doing the explanatory work is partly the generalization, of course, but the property itself here in the antecedent position seems to be implicated. We're saying ravenhood itself is helping us to explain. There is some nice psychological research actually showing that ordinary people will go along with this judgment, not just logical empiricists, but but just healthy, normal college sophomores will say that, yeah, we can explain why an animal has 4 legs by saying that it's a dog, and that dogs have 4 legs. Or here's another way. Here's a way that less healthy individuals, such as analytic philosophers of science, might be persuaded of the same point. As many of you will know, it's possible to hex a raven, okay, which just means to, as I say here, to say a fake magical incantation over it. So hexing is just this situation of having had the fake incantation said. There's no actual magic involved. Okay. We know that all hexed ravens are black. Maybe I shouldn't say all. We know that hexed ravens are black, or at least that's as true as saying ravens are black. But there's something disturbingly wrong with saying that the reason this particular hexed raven is black is because hexed ravens are black and this animal is a hexed raven. Okay? It implies a kind of relevance to the hexing that isn't there. Whereas it seems fine to say that this animal is black because it's a raven, and ravens are black. Or at least, let me say, there's a real difference between these two cases. So there's something explanatorily kosher about talking in terms of ravenhood, but not in terms of hexed ravenhood. The reason is, I won't go into the details now, all that has to do with that single reason constraint. The reason is that ravenhood, but not hexed ravenhood, is entangled with the coloration mechanism, so I think. Okay, now, I should say, let me see, yes, so first thing I'm going to do is just take that case and generalize it as broadly as I can. That we can, whenever we have an indirect causal generalization, so whenever we have a property that's entangled with an underlying cause, we can give an explanation. You know, I should say, these are not the deepest explanations, of course. You wouldn't declare science to be finished if these were the only explanations you can give, but still something that qualifies as explanatory rather than obfuscatory by citing an entangled property. So the blackness case, we can begin to give an explanation of the cars exploding after a rear-end collision by saying, it was one of those pre-77 Ford Pintos. Or we can explain the onset of type 2 diabetes by citing obesity. And in each of these cases, there's a sense. It's not direct causal relevance, because these are not direct causes. But there's a sense of explanatory relevance that the entangled property has. Qualifications. Okay. It's important to see here that the explanatory relevance of the property is to the thing being caused and not to the property it's being entangled with. Okay, so it's not in general true that F is relevant to P. It might be, but it doesn't have to be, and isn't always the case. It's rather, entanglement only, as it were, qualifies a property as relevant if it's entanglement to a cause and some causing gets done. So causation has to be a part of the story. This is why I think it's appropriate to say that it's as an indirect cause that the entangled properties are explanatory, not merely as an entangled property. And I'll say again, these aren't the best possible explanations. They're secondary in some way, in just the same way that indirect causal generalizations are not the best causal generalizations. We would rather know the true causes of things. But there's another form of knowledge we can have that's much better than simple correlational knowledge, which is indirect causal knowledge. And one reason it's better is because it allows us to explain. Or maybe I should say, it, being a little bit more cautious, we treat it as allowing us to explain. So, let me see. There's my. There's this. We should now understand this diagram. Just trying to remember why I have it here, as involving one causal arrow, but two explanatory arrows. Although, as I say, in a way, we don't understand the dashed arrow as it's self-explanatory, because that would imply that F can explain P. Rather, understand it as indirectly explanatory. It ropes in F and allows it to function also as an explanation of G, as an indirect cause. Okay. Now, how long shall I go for? Looks like I've been speaking for about 50 minutes. Shall I say one more?
You want to start winding up. I'm just trying to.
Let me say, I'll say one more controversial thing and then I'm done. Okay. Now, because entanglement is something that can become you can become entangled in many ways, and doesn't require you to participate directly even in the causal economy of the world. Entanglement can, in this indirect way, make just about anything explanatory. It can make irreducible properties, physically irreducible properties, explanatory. And I think something like ravenhood, I think, probably is physically irreducible. but it can still be explanatory by being entangled with something that's genuinely physical and therefore genuinely causal. It can make wide properties entangled. So I'm thinking here of wide content. The content of my beliefs depends in part on things outside my head. Yet the causal powers of my beliefs depend only on things inside my head. Philosophers have torn their hair out trying to understand, therefore, how I can understand my behavior in terms of the content of my beliefs, because the content of my beliefs seems too far flung to be genuinely causally relevant to my behavior. Answer, and I think people have given various solutions to this problem, and what I have to say in some ways is a way of thinking about those solutions rather than something that's totally new in itself. Answer, there are the broad content can get into the story by being related in the right kind of way to the internal, truly cognitive, neurological, I guess, cause. And the correct relation to bear here is the entanglement relation. So it's because something about certain beliefs tends to cause them to have certain properties that then have certain causal consequences within the head, that these contents themselves can be explanatory. Well, I apologize. I'm summarizing here rather than giving you the complete story. So apologies if you're not familiar with this story. I'm going to one more controversial thing. Okay. Like even completely non-natural properties, that is, properties that lie totally outside the world of material things, can be entangled with material things and can therefore be explanatory. A moral property, for example, can be explanatory, even if moral properties are wholly non-natural, as long as along with certain moral properties come certain physical properties. So it may be that along with being, I'm just going to rush into this example from Nick Sturgeon. This historian, Bernard DeVoto, is talking about this, the failure of the rescue expedition that was supposed to save the Donner Party that famously got trapped in the Sierra Nevada in the early winter snows, and a bunch of other settlers who were trying to get through the pass there. And the failure is pinned on the bad behavior of the commander of the rescue expedition, past Midshipman Woodworth. And not indeed just on the bad psychological makeup of Woodworth, but on Woodworth's abhorrent moral character. Now you might think of this morality as being something that simply is a certain kind of psychological property, but it's entirely available for you to think of it as being a property that lies totally outside the material realm. Yet because certain psychological dispositions, certain behavioral dispositions go along with being just no damned good, or maybe some slightly more precise moral characterization, that moral valence itself can be explanatory and can explain the behavior, Woodworth's behavior, and thus the failure of the expedition. So entanglement is very useful for solving a wide range of philosophical problems, and I'll be selling it after the talk, and you should buy something. Thanks very much.
You want to answer questions, or you figure you've been clear enough, so there's no... Okay, so I don't know everyone's name, so when I point you, Siddharth, right, if you told me your name.
Naji.
Naji.
N-A-J-I.
Okay. N-A-J-I.
Justin.
Justin. Okay. Okay.
Angie.
Angie's done.
A-S-J-I.
Oh, Angie, that's got it. Oh, yeah, Fons. So I've got Siddharth, Naji, Justin, Angie, Fons, Dimitri. Oh, okay. Yes, but tell me again. Dina and Jonathan. Have I got it?
No.
Oh, man. I'm sorry. B-I-W-E-I. And James. All right. Honestly, if you're not on the list at this point, well, we'll see. So, Simaf,
You gave me enough time to make an escape, John, but I wasted
yeah, wait,
So let me just give you an example which I think might be like an indirect causal generalization, but maybe not. Have a causal story to go with it. So if you look at the Newcomb's problem, and then you say one boxers win $1 million, right? So it's not that one boxing causes the predictor to predict that you will one box, because he predicted it in the past. But it still seems to be some kind of entanglement there in your notion of entanglement, that one boxing sort of reliably, there's no sort of causal story to tell about this, but it's still some kind of indirect causal generalization in the sense that you would give good advice to someone to one box, and in case you want to win. I know I'm getting into very controversial things, but yeah.
Isn't that just straightforwardly causal? Because being a one boxer causes the Newcomb genius to stick $1 million in the box, and then.
But that would be,
Take
people
$1 million.
tend to not accept that, right? Because your one boxing is in the future and of the prediction event, and so it can't be the case that the.
Oh, I was thinking of being a one boxer as being a certain kind of person, and so that being that kind of person is what, as it were, gives the Newcomb person their read. I suppose if you think of the actual act of one boxing.
That's what I'm thinking.
Now, that seems to be a case where the cause is not going to be an intrinsic property of intrinsic to the things. It's not what we have to ask ourselves: is this a case of entanglement? Is the cause of the, I guess in this case what's the effect here? Is the effect winning $1 million? Yeah, I mean, in some sense, of course. No, maybe I'm being overcomplicated. I mean, this is a case where the act does in fact gain you $1 million because you open the box and take the $1 million. But that's not really getting at the nub of the Newcomb problem, right? The question is how should my deliberation proceed?
Maybe we can talk about this after, because maybe I don't have it. But I just thought it's kind of generalization.
So we're going to have us Naji, and then is it Justin, Angie? I think I wrote Dustin. I wrote a word here that I can't. Who's next? I wrote. No, then Fonz, yes, and then after you, somebody. I wrote it as legible. Adina, Jonathan, B. Wade, and James. Okay. Oh, Dimitri. Yeah, Dimitri, that was you. Good. My writing was hopeless. Gotcha. Thanks. So look, honestly, let's keep it pretty terse and short because there's quite a list and we're just not going to get through. So.
So you described P at one point as like property, and the other, like in the other slides, is like mechanism.
Mm-hmm.
And for me, these two are very conceptually different things. And can you like tell me how you put them on, like why for you those two are the same thing, or are they?
Well, I'm thinking of the property is the property of possessing the mechanism, and so, or if you like, the instantiate. Think of the mechanism as being the instantiation of the property. If that helps.
What is instantiation?
Well, to have the property is to have the mechanism. So to possess the property is to have the mechanism, and so possessing the property just is possessing the various bits of the mechanism that work together to generate the effect.
Yeah, two just some short related questions. One, it seems like we also make generalizations like infection causes death, which can happen by multiple mechanisms.
Mm-hmm.
It also seems like based on entanglement, we might be able to say that fever causes death because the mechanism is becoming.
Yeah, so I mean, I don't want to say that, as I say, that it's illegal to make generalizations that are not either direct or indirect causal generalizations. I mean, first of all, sometimes we observe a correlation, and really we just have absolutely no idea what's going on. Is one thing one causing the other? We couldn't even, we don't know where to begin in terms of deciding what the appropriate property to put at the effect is, and we want to be able to say these two things are correlated and stop there without any further implications. And likewise, we may be in a situation where we're really not sure whether there's a single mechanism or not. My claim is rather that we try whenever we can to package up our knowledge in this way, according to this, first of all, our direct causal knowledge, mechanism by mechanism, wherever we can. So if I won't just say infections cause death, I'll want to sort of, for each possible mechanism by which infections cause death, have a separate generalization, and then likewise for the indirect ones. And yeah,
Let's move on. So Manji, you're next.
So I guess I'm curious, about to what degree do you think this kind of entanglement is due to a property of the English language? Because I'm thinking in English we do not have direct morphosyntactic cues for causality, so we tend to look for causality in terms of the syntactic structures or the semantic of the words. But in contrast, I think there is a language in India where they just have some postfix as a causality. So how would this kind of indirect causation demonstrate itself in this kind of language?
Well, one thing that's notable about the English case is that in some ways in English we don't have a very good way to show that we're talking causally, except by being very explicit about it. So maybe English isn't really the best language to be doing this in, but we get by because we know when I say ravens are black, I'm not just saying ravens happen to be black. I'm trying to say a lot more than that, and you interpret me as making this particular kind of generalization. So I think English is a middling language at best for thinking in these terms, but nevertheless we do think in these terms and express them in English, kind of getting by the best we can. Do you think, maybe you're thinking that in some languages might just carve up the world in a completely different way? It's possible. I mean, it might just be the hegemony of English speaking in science that's responsible for the hegemony of this way of dividing things up in science. It's not. I'm very much inclined to think it's part of human psychology generally, but it's true, I haven't given you any reason to think that today.
Okay, so Hans.
I have a question about the epistemology of the indirect causal generalizations. I was wondering whether we can only justifiably assert such a generalization if we are already justified to assert the causal mechanism behind it, or how you think about that relation.
Well, assertion is a strong thing. Part of what lubricates science is an understanding that publication is in some ways less than assertion. So I say, here's a model for this system, and I think the norms for presenting that model are weaker than the norms for just saying things in everyday conversation. Of course, there are some norms. I'm putting this forward as a serious candidate, and I'm saying I might not. There are various ways of doing it, but typically I would be putting it forward as a serious candidate. I'm saying you should take this seriously. We have some evidence, some reason to believe that this is a good model. But there may still be quite a lot of speculation and surmise in there. I think there's some underlying causal mechanism. I really don't know what it is yet, but a lot of my informal knowledge about the way things work leads me to believe that the causal arrow is going in this direction. It's not diabetes that's causing obesity, for example, although I could be wrong about that, but I have the sense that this is the way it goes. And a lot of our, especially when we're in this position where we don't yet know the mechanism, which is when indirect generalizations are the most useful, we're certainly not in a position to just stamp our foots and say, yes, this is definitely correct. Rather, our presentations of the generalizations will be a little bit more tentative.
Okay. So, Dimitri, I apologize for dropping you before, but you're in your rightful place in the list, so no injustice was committed.
Thank you. So I'm interested in, I see a couple of ways that the diagram could be more complicated. And I'm curious whether you would be happy to make it more complicated in that way, or whether it's important that it's not complicated in that way. So it could be that there's, just like I have F above P, I could have something else entangled on the effect side with G, and in that case I might want to make an indirect causal generalization talking about F's being generally with that thing that's entangled with G. And another way is that it could be that the causal relation down at the bottom is flipped, or that I just don't know what the direction is. And I was thinking this might be something if you have like a Phillips curve, where there's some kind of inverse relationship between unemployment and inflation, and well, maybe there's a common cause of the two, or maybe inflation causes unemployment, or maybe unemployment causes inflation, and both of them are sort of entangled with some lower level stuff that's doing some causal work. So are you happy with those kinds of indirect causal generalizations, or do you think
No.
genuinely explanatory is the same way?
No, I think these generalizations strive to put a certain directionality into the causal claims that they make. As you say, sometimes we're not in a position to do that. But there's a part of what's being attempted is to have that generality. Did I say generality? I meant directionality. The other question you asked, great question. When I was thinking about this, I thought, well, of course, we look at these diagrams of reduction, and you go down from F to P, and then you go over to Q and back up to G. That's the way it usually works. So you might say I was expecting something that looked a little bit more like that, but as I just kind of looked around and surveyed examples, it seemed to me that on the whole, that's not going on. I mean, but it would be certainly very interesting to identify a class of cases where this is what we do. We don't name the actual effect. We name something that, as it were, comes along with the effect, and see what kinds of rules govern that talk. In other words, what kinds of coming along with the effect we think is sort of sufficiently strong that we can, without qualification, we can simply make a claim F's a G and expect people to treat us as not as sincerely trying to communicate something rather than just speaking wildly.
Yeah, I was a little unclear about whether you have resources in entanglement to distinguish between claims that we think are actually explanatory and those that are misleading. So in the shield volcano case, it is kind of explanatory. In the obesity causes diabetes, it's misleading because, at least in that study, what was the causal factor was the content. So you can imagine obesity caused in cases where there isn't a high-fat diet. And so is there stuff in the theory that can guide you as to when these kind of claims are legitimate and when they're not? And I thought you might be getting at that at some point toward the end, but I went bypass.
Yeah, well, so for there to be entanglement, so in order to say, to assert the indirect causal generalization about obesity, it has to be that obesity is entangled with the underlying cause. And for that to be true, there has to be a tendency for the underlying cause to come along with obesity. In this case, it's because the usual cause of obesity is also a cause of type 2 diabetes. So it's important that, although even if it's possible to become obese without eating the diet, that almost always that's how it happens. And so in that respect, it won't be misleading in the sense that it won't just be picking out some small subset and turning it into a blanket generalization. Is that?
In the context of that study,
Yeah.
the mechanism other than
Yeah.
obesity.
I mean, so it would be certainly wrong to say obesity causes type 2 diabetes, intending, as it were, to express a direct causal generalization. I think in the, so in this, when we're, and I think in a scientific paper itself, I think we have to be more careful. But in the kind of informal talk that surrounds a scientific paper, it's okay to talk that way, as the PR people did when they issued the press release for this paper, which is where I got the obesity, how obesity increases, as long as you just have entanglement. But it's certainly true that you wouldn't want to dispense medical advice based on this generalization, given the availability of the direct causal information. So it's possible to use indirect causal generalizations to mislead people, but as long as they're taken in the spirit in which they're intended, people shouldn't be misled. So in other words, as long as it's understood as saying there's something about obesity that causes type 2 diabetes, that something being its typical cause, namely a high-fat diet.
Yes. Okay, so Susie has high blood sugar. Why does Susie have high blood sugar? We might say because Susie has type 1 diabetes. We often might speak in that way, and that would accord, I think, with what you're trying to say. What we're really offering is an indirect causal explanation for hypoglycemia. But what about this alternative story where instead of really offering an explanation for why Susie has hyperglycemia that points to her type 1 diabetes hood as being explanatory, even in an indirect way, why not just think that what we're doing is we're saying, well, the explanation for why Susie has hyperglycemia is the same explanation same causal story shared by these other people that all have type 1 diabetes. And that might be, in scientific context, a useful thing to say or to do, because then that directs us to where we can find the explanation. It's in an article on type 1 diabetes. So why should we prefer the story that saying the type 1 diabetes thing is providing an explanation versus this other story where it just points us to where the explanation might be found?
It's kind of explanatorily useful information without being itself explanatory information. I mean, that's a way it could work, for sure. So, and in a way, in some sense, and I think in a way that would make more sense. And it's a bit of a surprise if it's true that we treat the entangled property itself as being explanatorily relevant. But the reasons for thinking that we nevertheless do that, and sort of having to work out why that would be, are first of all psychological studies showing that people do find it to be a good explanation. It's not that I'm helpfully telling you where to look for the explanation of dogs' four-leggedness. I mean, you don't have any intention to look there, and perhaps not very much interest in developmental biology at all. That just seems to be an explanatory, if not a deeply explanatory answer to the question. There's that, and then there's the kind of hexing cases. So you might think I would be helpfully telling you, pretty helpfully telling you where to look for the coloration mechanism that's causing blackness in this raven by telling you that hexed ravens are black. Of course, you could always also look at a non-hexed raven, so maybe and you might object to what I'm doing on those grounds, but I've still given you some pretty useful information in terms of finding that cause, and yet somehow it seems like a really different kind of case. So it seems to me there's a quality there when I say ravenhood that's just missing in hexed ravenhood, even though both are helpful, maybe not to exactly the same degree, but to somewhat the same degree in the way that you're pointing out.
Okay. So we have two in the queue. It's Bigway and James. And I think I'm interpreting the movements in the room here. We are winding down to the... Go ahead. Please.
I have two questions. The first is that you said that entanglement can explain almost everything. So I wonder, in the case, if the entangle between F and P is due to the hidden common cause, do you think it should be counted as an explanatory case?
I think so, yeah. So we can explain, in this kind of shallow Raven way, we can say, yeah, the reason that volcano erupts effusively is because it's a shield volcano.
What if, like, we only observe something, but we don't know whether it is because of hidden common cause, or we don't know what is a hidden common cause?
So this is a case where maybe we see the usual effect of the common cause, but the actual common cause is not there. Then I think the explanation is incorrect. And the reason is that the complete criteria for the explanation being correct are not just that we cite an entangled property, but that the causal mechanism that's implicitly referenced by the generalization is the mechanism that was responsible for the effect. So just as it's necessary, let's take a direct case. Let's take a raven. It's black. It has the raven coloration mechanism, but actually it's black because you spray painted it black. Okay, there, saying it has the raven coloration mechanism is not the correct explanation of its blackness or its surface blackness. And the reason is that it wasn't the mechanism. The mechanism wasn't responsible. And just the very same condition applies to an indirect causal generalization that is true in virtue of the same mechanism. So it's not an additional principle, it's just bringing over all of the rules that apply to direct explanation using direct causal generalizations and also insisting on them in the indirect case. And it seems kind of crazy not to do that.
So you mean it depends on like how the entanglement is generated?
Well, no. So here I'm just talking about whether the mechanism is responsible for the property or not. And if the mechanism isn't there, then clearly it isn't responsible. But another question you might ask is, what if the property is there and it did cause the thing to be explained, but the reason the property that is there isn't the usual one, but one of the oddball ones that isn't is allowed because there's some slop and entanglement, but isn't the big single reason. So, the coloration mechanism is there because scientists took some raven that lacked it and implanted it. I'm inclined to say in that case also that the integral property is not explanatory. So it's got to be that, as it were, both arrows do their standard thing.
And the second question is...
Briefly now, because most people got one question, right? So you're going to make this brief?
It's about what is entanglement. So can it be summarized by logical relations, causal relations, and also like mathematical relations? Are there anything else?
Yes or no would suffice.
Yes. You mean what different kinds of relations could be responsible for entanglement?
Yeah. So besides like logic, causal, and mathematical.
I mean, everything. I've listed the criteria for entanglement. Anything that allows those criteria to be satisfied. So maybe to add to the list semantic facts.
Yeah, I was moved by the interest of entanglement, but my interest was in the semantic commitments of your review. It sounded like you were saying that there is a certain class of natural language generics, at least in English, which have as their truth conditions, at least in a context, something like what the conditions you give in terms of entanglement. And I was thinking that is going to commit you to the existence of the true reading of certain negated generics, and I'm wondering if those are found. So take one example you gave, which is bread nourishes. So it should be true that if we find any failure of entanglement, that there should be at least one true reading of. It's not the case that bread nourishes, right? Because there's at least one true reading of bread nourishes that is the generic one that you want, right? The scientific one. So it should be true to say, for example, if it turns out that we investigate bread and it nourishes you and me, but in virtue of a property that it has relationally rather than intrinsically, that it should be true to say that it's not the case that bread nourishes.
Mm-hmm.
And I was thinking, I'm not sure there is such a true reading. I'm not a philosopher of science, much less a scientist, so I know that you're interested in readings that are especially prevalent in those contexts, but so.
Yeah, so in a case like this, maybe at least it would be okay to say something like, it's not really the bread that's nourishing you. Does that seem okay?
I don't know, I'm thinking that...
I mean, you kind of gave more of a sketch of a story than the story, which is perfectly reasonable in this situation, but I'm just trying to...
There's some counterfactually robust property of bread such that when you or I or any other human eats it, it nourishes us, which just happens to not be intrinsic, for example. I don't know.
It's not an intrinsic property of the bread that we get nourished, so it's like...
Yeah, but it's still
it's a bit of a...
We get nourished as a result of eating it.
I mean,
I don't know.
It's a tricky situation to get your head around. I mean, what about something like if all the ravens are red, and actually it's just this mad spray painter who just spray paints all the ravens red. So is there some sense in which it would be right to say it's not the case that ravens are red, even though actually all ravens are red? Is that getting at the nub of your worry?
Yeah, that's...
I mean, I'm not a philosopher of language, and I'm not sure, I mean, there seem to be, at least there's a kind of a pragmatic first line of defense for me, because that would be a very peculiar thing to go around saying in this situation, even if there were a sense in which it were correct. This really takes us into mysteries about generics and maybe negation and assertability where I feel any comment I make will be under-enlightening. But it's a nice question, thanks.
You willing to take one more question at the back from Neda, who will make it very short?
Sure.
So all reasons are black, and here there's something about the raven, intrinsic to the raven that makes it such that it's black. How did this map on to what you say the end about non-rigidity? I'm just trying to see.
So it's important that it's the property has to be intrinsic to the F's, not to F hood. Okay, so it's the mechanism has to be literally inside the ravens, but it doesn't have to be a part of ravenhood. And likewise, the psychological dispositions of the sort that lead to failed expeditions have to be inside the people who are no damned good, but not part of the property of being no damned good, which would be impossible if it were a non-natural property.
Okay, and with that, we can now move to our closing ceremony.
Oh. I see rain is in the forecast, so that's very thoughtful. Thank you.
Student has had the kindness not to embarrass you with a sumptuous banquet, but we do have some light refreshments to offer you, so please do come and join the speaker for some light refreshments.
I can take the microphone.
All right.
This is probably wise to
Yeah, so you can have private conversations.
Well done. You must be tired now, I'm sure.
All right.
Good.
For us is every time we eat bread, like beams of a true reading in that context of like, no, it's not primitive.
Turn out logical.
Pick a case where it's a property that causes us to be more efficient.
So there are a few philosophers in the audience, but of course the reason I know them is many of the philosophers.
So, for example,
Thus, I show you that.
He told us
it has a certain nutritional laws.
Epistemology.
Something like that.